convolution. Let's assume that there is a system. Let's denote the system by a block, right? This is a system. Normally the system's response is denoted by the h, right? This can be continuous or discrete, so I can write h of t or the h of n depending upon whether it is a continuous or discrete. T is the continuous variable. So we represented the system using this h of t or h of n. T is the continuous variable, n is the discrete variable. Okay, so similarly the input can also be modeled using x of n for discrete or x of t for continuous, right? So output becomes y of n for discrete or y of t for the continuous system. Okay, now the concept of convolution arises because of two properties of such systems, right? So why to represent that, we'll see. Why exactly the convolution is written in the equation format, which says that summation of x of k h of n minus k. We'll see that. Okay, but before that there are two properties. The first property is called as a linearity, right? This is every system need it is not necessary that it has to be linear, right? But we try to bring the linearity in place because whenever you say the system is linear, things become very simple for you, right? In the sense, if you give any alpha k as input, right, the system's output is expected to be some beta k, right? It's something like uh, I'll make it more simple. So if you try to represent, say, a system's input as a1 times alpha 1, see, this is m into x format, a1 alpha 1, a2 alpha 2 plus a3 alpha 3, etc. In the sense, whatever input you give, which is x of n, if you split it into this format, you see this is linear. m1 x1 plus m2 x2 plus m3 x3, etc. You provide that as input, then the output should also be able to represent in the same format. This is a1 beta 1. See, the same constant comes into picture, a2 beta 2 plus dot dot dot. You see, only alpha is getting changed into beta. My constants are remaining same, right? If this property gets satisfied by a system, you call that system as linear, right? So that's the first thing. And second basic property which is expected, because whenever you have an unknown system, in order to explore the properties of that, right, you try to make that system as simpler as possible. That simplicity comes into picture when the system is having these two properties. Okay, the first one is linearity and the second one is time invariance. Okay, you might have studied this somewhere. It's first I'll give an example. What is the time invariance, right? Let's assume that I have a circuit with me which is a system. Okay, and I assume that my circuit is an amplifier, right? Whatever you give, it will double that and it will give it at the output. So this is a simple circuit. You give input voltage of 2 volts, output is 4 volts. You give input as 8 volts, output is 16 volts, and so on. Very simple. Okay. Now the time invariance is the property of any system which satisfies uh, there is no change in the response of the system when the time is uh, changed. In the sense, let's say I give 2 volts today, right? Today 6 o'clock, right? I get an output of 4 volts. Fine. Now you see, you give the same 2 volts tomorrow, anytime. Output is still same. Output will not change. Output is not dependent on the time variable. right? There are some systems, today you give an input, the output is different. Tomorrow also you give the same input, don't change the input value, but the output is completely different. See, the output is varying with the time. Okay, at what time you give input, output changes according to that. That is time variant system. But all the systems which we consider, right, in this chapter, you can see the chapter heading which you had sent me, right? So it says that LTI system, which is linear and time invariance. Okay, so this means I can try to represent this in this way. So x of t, let's assume that x of t produces y of t. In the sense, right now your t is the current time. So you give an input x of t, output is y of t. Now what I do, I add 12 hours to that. For example, this is x of t minus t naught, shift in the time. Output should also get shifted by the same amount of time, no change in the amplitude. Right? So x of t shifted by 12 hours, tomorrow I'll give, right? Or 24 hours, tomorrow I'll give. Output will also come tomorrow itself, and with the same amount amplitude whatever we had earlier. So that is what is the meaning, right? These are the two things we need to consider whenever we go for a uh, the convolution, right? This is assumed. Sorry. Now, so now actually there is a branching happening here depending upon what alpha k you use, right? You can see that I mentioned that the linearity is a concept where any alpha k is given to the system, beta k is the result, which is expected to be known, right? In the sense, I give 1 as input, what is the output I am expected to know, right? So if this alpha k, I'll bring I'll give you a deviation here just to make sure that you understand what else we can study from this concept. Okay, the first one, if you try to represent this alpha k as delayed impulse, in the sense delta of t minus 1, delta of n minus 1, etc. If you try to represent this alpha k in the form of delayed impulse, this results in a concept called convolution. Convolution is simply take an alpha k, represent any input in the form of delta functions, okay, impulse function. At the same time, if I choose this alpha k as, now this becomes very clear, if you take it as a complex exponential, what happens? Can you guess? It's a Fourier, that's all. So you see that alpha k is changed, that's all. Okay, this is Fourier analysis. Right, so directly I'll jump into the convolution now, right? The basic requirement is that now the convolution comes into picture because of the following representation. We try to, let's say that I still have the same block with me. I have some h over here, h of n or h of k. I have some x as input, we have some y as the output. All right, now let us say I have a signal, right? So let me assume that this is the signal which I have. So this is a discrete sequence. Okay, now this is 0, this is 1, this is 2, this is 3, this is the discrete axis n, this is minus 1, maybe I assume some other value minus 2, and so on. Okay, this is some sequence. I don't want the amplitude as of now. So you see that the if at all this sequence is x of n, right, the value at 0 is x of 0, isn't it? This is value at x of 1, x of 2, value at x of minus 1, and so on. I have different values coming up, right? Now how do you represent? See, the point says that I have to represent, I have to take these alpha as delta function, okay, impulse function, and I need to use some constants to multiply those alpha to get the equation, right? That is x of n. Now you see how I write that. So this means in order to represent this using the required format, I'll write x of n is equal to, So I'll write only the starting from x of minus 1. I have many points before this, whatever is at minus 2, minus 3, and so on. But anyway, let me stick to the start from minus 1. So see, this is the constant value. Alpha is this x of minus 1 into delta of n plus 1. Are you okay? This is on the left side, plus x of 0 into delta of n, correct? Plus okay, x of this is x of 1 into delta of n minus 1, right? And so on, correct? So now you can compare this. This is equal to, say, alpha minus 1 into a delta function, correct? Because this is the constant. Sorry, just a second. Because alpha is my function, so I cannot change that. So let me write it as a1. So this is a minus 1, because a into alpha, that's what we wrote earlier. A1 alpha 1, a minus 1 alpha minus 1, a naught alpha naught, plus a1 alpha 1, plus dot dot dot. You can compare, right? So now we are writing in the required form. So in general, I can write this in the following notation, but therefore I can write the x of n is equal to, right? You can see there is a summation. The summation for k is a shift, right? Minus infinity to plus infinity, right? This is x of k into delta of n minus k. Are you okay? So this is how I am representing the input to a given system, right? When the input is, you are able to represent the input in this format, we are able to write this is the first requirement. I should be able to represent any given input and in the linear format. Now, because of linearity, what happens at the output? So, first I'll apply linearity. Linearity in the sense output should be, right, in the same format as input, correct? So if you give a times alpha at the input to a system represented by h, you should get the a times beta, because alpha is getting converted into beta. Alpha remain, the a remains as it is, correct? So this implies if x of n is given as input, what should happen to y of n? Y of n is equal to, it also should have the same format like the input that is denoted over here. So the same format indicates that this is summation k is equal to minus infinity to plus infinity. See, a remains as it is. What is a? X of k, right? So that means there will be x of k as it is. Okay, then this delta k, see, alpha becomes beta, right? So for the time being, I'm not aware of what is this beta, correct? What I do, in the sense, if I give the alpha equal to delta of n minus k, what becomes beta, I don't know, right? So for that reason, I'll simply write this as hk of n. Let's see what is this later. Okay, so this is, I'm simply applying linearity now, and I'm getting this answer. Let's hold on to this. Now for this itself I need to modify, because my system is time invariant as well, right? So I apply the time invariance now. So when you apply the time invariance to this, right, I should be able to represent this. So I know that delta of, this is delta of n minus k as input. What is delta of n? It is 1, right? I'll come to that point in time. So I am assuming that you pass it through the system represented by h, you get sorry, hk of n, correct? This is what hk of n, this is what I just assumed. I know that we know something. We know that if you give delta of n as input, what comes at the output? It is h of n, correct? This implies apply time invariance now. So when I apply the time invariance, delta n becomes delta n minus k, means what? H of n becomes h of n minus k, correct? So this is equation 2. Put 2 in 1 directly, right? This means you get your final output. Therefore the y of n is the output of a system, right? Becomes, simply I'm changing I'm going to put the equation 2 in equation 1, right? So this is summation. Now k is equal to minus infinity to plus infinity. X of k is my constant value, so it remains as it is. Only hk of n becomes now h of n minus k. Just compare this with the standard definition of convolution, right? So this itself is the equation of convolution. So how do you calculate the output? When input is known and the impulse response is known, right? You use this, right? This is called as the equation for convolution, right? But in general, right? This is the we use the concepts of systems to define the convolution process. Okay, but in general, you can convolve any two functions like x of n convolution y of n. This is possible, right? Any two signals. This is represented as summation. K is minus infinity to plus infinity. Keep one of the signal as it is. This is x of k. Second function, you shift and flip. Okay, I'll come to that point now. So this is n minus k is called as a convolution between any two signals. Okay, so straightforward, and actually this is simple, right? So this particular equation is called as convolution sum. The technique which we are applying here is called as convolution. This is a sum. Why it is sum, I'll tell you now. Okay, when we go, because the difference is that when you go for the continuous case, the equation becomes an integration. That's why the convolution of two continuous functions are called convolution integral in continuous case. So the process is convolution only, but it's not, you are not taking a sum over there, you are going to integrate over there. Okay, so let's go for a problem in a very quick fashion. We have two options. Okay, the second option is pretty simple, but I don't want to go there. I want to go with the one standard technique which is straightforward. Okay, now let me write the equation once again. Let us say I have y of n is equal to x of n convolution h of n, right? This is as given, as per the equation. This is k is minus infinity to plus infinity. This is okay, x of k into h of n minus k, right? I understand that now uh, the time variable is k. Okay, time is not n. So though I am, my final answer is n, right? I know that whenever you have a summation over k, right, the k will vanish after you take the summation. It's something like an integration, right? If you say integration of x of t dt from a to b, I know that in my answer there is no t, because t will vanish and you substitute a and b to that. Same thing happens here, right? So k will vanish because you are going to put k as some values a to b, right? In this case it is minus infinity to plus infinity. So I am not going to have the k in my final answer, but for the purpose of convolution, k becomes your variable. Okay, k is my variable. In the sense, the time axis is for x of k and h of n minus k. If I try to plot x of k and h of n minus k, k is my variable, not time. N is not, n will not be there. No, I'm saying what I mean, I'll repeat, right? So if I'm trying to plot these two functions as it is, right, I'm trying to plot them, right? Because my process is, right, to perform x of k here and h of n minus k here, right? Now you see what will be the variable is k. This is what I'm trying to say. Okay, my axis is k. Okay, my axis is not n. Are you fine with that? Because you can see the equation says it is x of k and h of n minus k. Right, now I will bring another concept in the middle, just because I have h of n minus k in place, right? What are the operations you see over here, right? if that is, I have, let's assume that I have x of n. Okay, or I'll make it more simple. I'll be in the same domain. I don't want to change the domain. Let me write I have h of k, right? Let's say I start with h of k. If you convert h of k into h of k plus n, right? What is this operation? This is a shifting operation, correct? I am shifting. Now, correct, right? I shift, and now you see that I'm converting this into h of minus k plus n, because this is n minus k, right? N minus k is minus k plus n. K becomes minus k. So when k becomes minus k, it is something like t becoming minus t or n becoming minus n. That is called as a flip, right? You are flipping the signal, correct? So I can see that I have a flip followed by the shift, right? So these are the two operations I should do on the second signal. First signal fixed, no change. It's not moving, it's not getting flipped. So this is the fixed signal. The first signal which you write x of k is going to be fixed. Second function which you are writing, there is a flip and there is a shift. Okay, so now the idea becomes very simple. You see, keep first function as it is. Second function you flip and get ready for shifting. How much shift? Shift is decided by k. Whatever value k you put, so many shifts will be there. K is 1, k is 2, k is 3, k 4, etc. Okay. Then take a product of those two functions. Take a sum. This is what you are going to do for convolution in discrete. Okay, now I'll make the same thing very clear, right? So by taking an example, let's go to a quick example. All right. So fine. Let's say that the signals are like this, right? So the question is to convolve x of n is equal to, fine. This is equal to 1, 1, 1, and h of n is, say, okay, I'll add one more one to this. So the first signal is of length 4. All right, so this is 1, 1, 1, 1, and the second function is simply 1, 1, 1, 0. Okay, fine. Under this condition, what we do here is that, just to elaborate the process, just to make things very clear, I'll hold on the I'll try to write the index as well, for time index, right? So I know that k is my index, right? I assume that this is time 0, this is time 0, because x of 0, x of 1, x of 2, x of 3, those values have been given. H is also given from assuming starting from 0, because you can see that the signals can start from anywhere in time domain, right? So only just for that purpose we are trying to keep it in this way. All right. Okay, now so I assume that k will start from, k actually is expected to start from 0. Okay, so this is 0, k is equal to 1, k is equal to 2, k is equal to 3. Maybe I need few more values, 4, 5 I write, and on the left hand side also I'll write few values, -1, -2, maybe -3. This is the k value. Anyway, it's not, I'm not going to use it for any calculation, but this is just to hold the account of time. Okay. Also, let me make it a table so that this can be referred at any other point of time. All right. Okay. Now what I do here, I'll write the signals accordingly. Right. I first write the x of k, because I'm writing in k because my the equation is in terms of k. Right. Equation for convolution is in terms of k. So let's write this is x of k. So you see where x of k begins. X of k is beginning at 0. So this is the signal 1, 1, 1, 1. Okay. Then I should perform h of n minus k. But before that, let me write the h of k. You can see that h of k is also starting from at 0. So this is the 1, 1, 1 and a 0. You will make the length equal. Now, as you know, the h of k is not going to change. Correct? H of k is fixed. So what I do, I'll put a box around x of k, indicating that it's not going to move. It's going to be fixed. Okay. Also, which means that sorry, what I do? Okay. Now you see the process. Let me go back to the equation of convolution. Right now what I have is x of k. Fine. I don't have h of n minus k. I have simply h of k. But I want h of k to be converted into h of n minus k. What are the operations you are going to perform? Flip and then shift. So when there is k, that means there is a shift by k amount of, right? K, there is a shift by k. Okay, now first let me do, so the process says that you have to shift, you have to flip, my mistake. So what is flip? Flip is simply h of minus k, correct? But what I do, I'll try to write this in a different way. Now you can see that this is nothing but I can write that this is n is equal to 0, right? Are you okay with that? Because when n is 0, this is h of 0 minus k. That's why I don't have any term coming up, right? So this is n equal to 0 here. Okay, so h of minus k is what? What do you mean by k becoming minus k? Have you heard of flipping the signal? What do you mean by flip? Flip means everything on the right side of your y-axis will move to the left, correct? Reflection, that's what is a flip, right? Okay, so this means whatever is at 0 will remain at 0. With respect to h, that is this signal, whatever is at 0 will be at 0. So that means 1 will be there as it is. This one goes to this side because plus 1 will become minus 1, plus 2 becomes minus 2, plus 3 goes to minus 3 and so on. Correct? So that's what is a flip. So I'm going to flip the signal now because my equation says to do so. Right. So this one comes over here. The right side, the one which is present at 2 will come to minus 2. The 0 will come to this point. Okay, this is the flip. Now, if you give a n value, right, that n gives you the shift to right by that much amount. Now you can see that all these values are zeros because signal does not exist over here, correct? So I'll write those values as zeros. Okay, so this is 0, 0, 0, 0, 0, 0, 0. Now you see this is, yeah, correct. Yes, yes, you will make the length of the signal same. So same, so whatever we study in one dimension, we extend it to the 2D in case of signals, or even for 3D or multiple dimensions when you go for a higher dimensional signal process. Okay, fine. Now this means I can actually calculate, right? Let's go to the equation. I'll write the general equation over here. That is what I want to calculate is summation of whatever x we have, that is x of k into h of n minus k. This is what I want to calculate, correct? So in this case I know that n is equal to 0, correct? So this is what I want to calculate. I want to calculate summation. I want to calculate the summation of x of k. See, when n is not there, what you should write? This is h of minus k, right? In the sense, I have a x of k here. This is x of k. Multiply that with h of minus k. Take a sum, right? So you always do this point by point. So why we actually put a box around this, because only these values you need to calculate. This is 1 into 1, 1 into 0, 1 into 0, 1 into 0. That's all. Outside this, all zeros exist. So it means there is no meaning even if you multiply. Right? So what's the answer now? This is equal to 1. Correct? 1 into 1. 1 into 0 plus 1 into 0 plus 1 into 0, because there is a summation, right? So this is equal to 1. This is what I am going to call, I will slightly move right. So this is what the answer, what you are writing here is y of 0, right? Because n is 0, right? So this is y of n. General equation for y of n is this, correct? Now since n is 0, you are calculating y of 0, that is equal to 1. Okay, now I'll move further. Now I make n equal to 1. So this becomes h of 1 minus k. Shift it right by 1 unit, because flipped, so moving will not be left, moving will be towards the right. So every sample will move to right by 1 unit, right? So the one which was here will come to this position. This one comes here. All zeros will remain as it is, right? So the one more one is there, 0. On the left hand side, you have n number of zeros available. So it moves down. Now you see, you multiply 1 into 1 plus 1 into 1, that is 2 plus 0 plus 0, right? So you can see that this implies the y of 1 is equal to summation xk as it is, no change, but h becomes h of 1 minus k because you shifted. So this becomes equal to 2 now. So the second sample is 2, the result of convolution, right? Then go ahead, h of 2 minus k. Once again shift everything to right by 1 unit. So there is one more 0, the 1 1 1 0 0 0. Okay, so now this is 1 into 1 plus 1 into 1 plus 1 into 1, so 3, right? So this implies y of 2 is equal to summation, this is x of k into h of 2 minus k. So this is equal to now 3, right? Do the same thing. So there is a point to stop. You will come to know that now. Okay, when to stop. So no, you are multiplying 1 into 1, this 1 into 1, this 1 into 1. So 1 plus 1 plus 1, 3. Correct? Fine. Do you have any doubt? Okay. So the next shift will be 3 minus k. All zeros are here. 1 0 enters inside the region of interest. This is 1 1 1 0 0. So this means now I am calculating y of 3 that can be calculated as per the equation. Summation k is minus infinity to infinity. This is x of k into h of 3 minus k, because you provided 3 shifts so far. So this is also equal to, you can compare, this is 1 plus 1 plus 1, so 3, right? Okay, fine. Then h of 4 minus k, so all zeros, 2 zeros enters inside our region of interest, that is between k is 0 to 3. This is 1 1 1 0, the one of the 1 goes out. Okay, so this implies y of 4 is equal to the summation, this is k varying from minus infinity to infinity, x of k into h of 4 minus k, so that is 2, I guess. All right, then h of 5 minus k, so 0 0 0. Now 3 zeros are inside, 1 1 1 over here. So this no, this is not symmetry, because here it looks like symmetric for you because I consider all numbers as ones, but it's not required, right? I can make the numbers to be uh, like 1 2 3 4 and 8 8 20, right? So see the number, then this will not be symmetric. Only in this case I wanted to keep this problem as simple as possible, because my intention was to show you how the convolution happens. All right. It's not necessarily be symmetric because it depends on the other signal what you are considering, right? So in this case, it looks like, okay, all samples are same, so may look like symmetric for you. Okay. All right. So this is y of 5 that is equal to summation xk into h of 5 minus k. So that is equal to 1, right? Now you give a next shift and just to check what happens. Okay. So h of 6 minus k becomes 0, 0, 0. You see all zeros are inside our region of interest, correct? So because the 111 is completely moved out of the box. Now you multiply 111 with this last row, it's always 0, right? So which means after this n equal to 6 onwards, 6, 7, 8, 9, dot 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 till infinity. What is the product? Check out what is the product now. 1111 and 0000. 0. So now my question was, after this, any amount of shifts you provide, right? More and more zeros keep coming in from this side, correct? So which means my product is 0, so I don't have to calculate that, right? So only till n equal to 5 is your answer, right? So I'll write my, therefore, let's write, I'll write the answer. Therefore the y of n is equal to, in terms of the signal samples, this is 1, 2, 3, 3, 2, 1, right? So now if you want, see, we started with the concept that x of n is represented in the form of linear equation, right? So linear equation was 1 into delta of n plus 1 into delta of n minus 1 plus 1 into delta of n minus 2 and so on, correct? So that's what 1111 stands for, correct? This 1111, same thing you can apply for the h of this thing also, but the h of n is the impulse response, right? Right, that is 111. Now my convolution concept says that you should be able to write even the, what you call, the final answer y of n also in the similar format, correct? It is expected to write in the same format, so that is possible. Now you can see that this is equal to first sample, this is delta of n, correct, plus next sample 2 times delta of n minus 1, next sample 3 times delta of n minus 2 plus 3 times delta of n minus 3 plus 2 times delta of n minus 4 plus 1 times delta of n minus 5. You see that it's coming in the same way what we expected. That's why if you try to represent the alpha values as impulse response, impulse, okay, basically shifted impulse, delta delta n minus k delta n plus k, like that if you write, the concept is called as convolution, right? So this is what you are going to do in convolution, but anyway, I'll tell you a quick method to do the convolution. Okay, so all these things, these tables etc are not required if you are in a hurry or if you want to verify the answer of a convolution. Okay, just take this. So let me consider the same signal. I have x of n equals to 1111. This is called as a the shortcut method. All right. So h of n is given as 111. Right. So anyway, you don't have to make it pad a 0 here to make it equal. Keep it as it is. Doesn't matter for verification. Okay. So take one of. I have to make a table now, but not the table which we have done just now. So it's a very simple table. So write. If you have 4 different values for the first signal, right? You can write 4 columns, okay, and the number of rows equal to the second, the length of the second sequence. All right, so I can say that it is 3, right? So what I do, I make 4 columns and 3 rows and write the values over here. If it is 1 2 3, you can write 1 2 3, otherwise the other signal, first signal goes on the top, second, and fill it right with the product 1 into 1, 1 everywhere, 1 into 1, so it's 1 1 1 1 1 1. Okay, now to get the result, you read it diagonally. So you see this is 1, 1 plus 1, 2, 1 plus 1 plus 1, 3, 1 plus 1 plus 1, 3, 1 plus 1, 2, 1. So you see the answer just now we got is the same thing, right? This is 1, 2, 3, 3, 2, 1. Right, same thing you get here. This works for any signal like 1 2 3 4 and 8 minus 3 minus 4, anything you write, this works. Quickest way to do the convolution. But just to show you what exactly happens, right, with the two signals I had to draw this whole thing. All right, so you understand now that we had two signals. The first signal is kept as it is. That's because you in the equation you have x of k, right? K is my variable. I'm not shifting, not flipping. But for the second signal there is n minus k. The n minus k ultimately indicates that you have a shift and you have a flip. So because of that I had to perform the flipping operation. H of k becomes h of minus k, then take a product to get y of 0, right, and so on, right? Then keep shifting by adding a n value. So you can see that this is what happens and you get the convolution results in this fashion. Okay, this is a straightforward way of performing the convolution. Okay. Now you have a doubt related to the continuous, right? What exactly is going to happen when the signals become continuous, right? So now I'll go to that answer. So if the signals are continuous, then we have we have change in our equation. Okay, so for continuous signals, we call the convolution as the convolution integral. It's not convolution sum because we have change in the equation. This is y of t is equal to, now this is x of t convolution h of t, right? This can be represented as, now you see I have to change this to a new domain. I'll call it as a tau. Tau is minus infinity to plus infinity, similar to the what you call k is minus infinity to infinity. Now tau, okay, it should be x of k, so new variable, so this becomes x of tau. H of, it is n minus k, so this becomes t minus tau d tau. So this is the equation, right? Why it is not summation? Because I have continuously varying values. Yes. True. It's a continuous impulse function. You see that this was a discrete impulse, correct? This is delta of n at 0, n equal to 0. Now this gets replaced by this impulse function, delta of t, correct? At t equal to 0, this is the t-axis. So you know the meaning of this arrow mark, right? Amplitude is infinity, width is 0, right? So this is not that, right? This is exactly 1, amplitude is 1. So correct, unit impulse in continuous is different compared to the unit impulse in the discrete, right? Okay, so this is what we are trying to do now. So let's consider, I'll directly go to a problem so that it becomes very clear, right? Okay, so now let us say this is a question. Convolve x of t is equal to this is 1 for t greater than or equal to 0. This is 0 else. This is the first sequence. With the second sequence, that is h of t is e to the minus alpha t, right? This is for t greater than or equal to 0. This is 0 else. This is these are the two sequences given, two signals given. All right. Now, so again, alpha is greater than 0 is what is mentioned over here. Okay, fine. So now let's try to plot, right? Instead of making the table, I will plot and I will show what's going to happen. Okay, so let me plot the two sequences over here. Let's say this is my y-axis and this is the x-axis. is e to the minus alpha t, so decreasing function. Okay, see, alpha t is increasing, but this is e to the minus alpha t, right? Okay, so first function I'll write now. You see the domain changes. I have to write in terms of tau because my equation says it's in tau, like I did in the previous table. So I changed n to k when I wrote the table, right? So same thing is what I'm going to do now. Okay, so this is now x of tau. So x of tau is 1 for t greater than 0. It's actually called as a unit step function, correct? It's a step function. It goes till infinity, right? To infinity it will go with the amplitude is 1 at tau is equal to 0. Okay, similarly, I have to draw the second function now on the same axis. So this is the tau axis. So this is h of tau, right? So anyway, you put t is 0, it is e to the minus alpha into 0, e to the 0, which is 1. So that indicates that it starts from 1. And as the time increases, this will decrease, right? So this is the function. Okay, now just recall what we did in continuous case, right? Sorry, discrete case. The second function, first function is going to be fixed, right? So that's why just to relate what we did earlier, I'm going to put a something like a bracket to this function, just to indicate that okay, I'm not going to vary this. This is fixed now. Okay, the second function, what we did, you flipped first. So flip it, right? So that's my first step. Yes, flip it towards sorry, the function is present on the right hand side, so move it to the left side of the axis, of the y-axis. So x-axis is still tau, and my function, this is called as h of minus tau. So and this is 1, start from here, goes like this. So this is going till minus infinity now. Now, as per the rule, you have to take a product, correct? So you take a product and you integrate, correct? Now, actually, the equation says that the tau should be from minus infinity to plus infinity, correct? But in the sense, starting from minus infinity till 0, this is 0, right? You see that there is no x of tau does not exist. X of tau is 0. No. As of now, when you take a product, you see, remember what we did earlier, right? Taking the product of point by point, in the sense 1 into 0, 1 into 0, 1 into 0, 1 into 0, because right side its signal does not exist, correct? At the same time, left hand side, this signal exists, but on the top I have zeros, correct? So what's the product now? No, you see that if it's something like 0, 0, 0, 0, 0, and then I have 1, 1, 1, 1, but my second signal is having some values here, some x, 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 x on this side, and 0, 0, 0, 0 on the right side. You see that that's what is happening here. This is 1, product is 0, right? Correct. So the product becomes equal to 0, right? So your convolution result is 0 now. Are you okay? It's fine, right? Okay, so that's what is the meaning. But before that, what I do, I'll tell you something more, because continuous is little bit more trickier than the discrete was. Okay, so what I'm doing, I have a t value coming up, right? So in the sense, if you have a t value lesser than 0, correct? So when t is less than 0, I'll write now this, I'll write 1 point now. This is h of t minus tau with the t value lesser than 0. Okay, what happens? Where will be your h of tau? Right, h of tau will be present on the left hand side. This is the tau, right? Let me write this. Now you see, if this is the condition, h of tau will be somewhere here, right? Because t is the amount of shift. T is less than 0. T less than 0 means this will be the t, right? This is amplitude 1. For any value of t less than 0, your tau will be, if t is minus 100, this may be here. If t is minus 1, this may be, sorry, t is minus 1, this is here, correct? T is minus 10, this is here, correct? T is minus 100 and so on. So for any other value of t less than 0, my function will be completely present on the left side. Left side of 0, which means what is the product? For all these values it is 0 until this reaches 0. Even if it is reaching 0, you can see here the t is 0 here, correct? So for t is 0 and less than 0, there is no product, correct? So that's my first part, because the answer for continuous convolution, right, is written in parts. It's not a straightforward answer is not directly written in the form of equation. Okay, so first part of my answer is that t less than 0, this the partition varies from problem to problem, but in this case I can see that when t is less than 0, what I say is that my statement goes like this. The statement is that there is no overlapping between x of tau and h of tau, right? Why? Because x of tau is on this side, the right hand side, right? Whereas my h of tau is completely present on the left hand side. There is nothing overlapping. There is no overlap means there is no product. So because of that reason, the convolution result is equal to 0. When the product is 0, there is no meaning for integration. Correct? So I can say that when t less than 0, x tau and h of t minus tau, right, they do not overlap. Correct? So this means the answer y of t is equal to 0 for t less than 0 is my first part of the answer. Okay, now let's make a t which is positive. So my next condition is that I'll write h of t minus tau itself, but now you see t greater than 0, right? When t greater than 0, what happens? Can you guess? Correct. So this is the tau. So now I can see that this will be a positive t and function looks like this. Correct. Now this is 1. Okay. All right. Now you tell me, how do I calculate the convolution? It's possible. Correct. It's actually, see, there is an overlapped region now. Correct. So this is the common area between the two functions. Right. So that means there is overlap, and from where to where you have overlap? Overlap region begins at 0, correct? And it ends at a t value, correct? Whatever is the t, till there you have overlap. So t is 4, overlap till 4. T is 10, overlap till 10 from 0, correct? So that's the next case coming up. So for any value t greater than 0, right, the x of tau and h of t minus tau overlap. They overlap from 0 till t, right? When I have the overlap now, so I can do the integration, correct? So this implies calculate y of t. Y of t is equal to integral. Now the overlap region is what I am supposed to write, right? So this is not minus infinity to infinity. This is 0 to t. What is the first function? It's 1, right? What's the second function? It is e to the minus alpha. I cannot write t now because second function needs to be t minus tau. H of t minus tau. Wherever you have t, you should write t minus tau, and the variable is d tau. So this is equal to integral 0 to t, normal integration. Okay, so this is e to the minus alpha t into e to the minus alpha tau d tau. So e to the minus alpha t is a constant for us as it is. E to the minus alpha tau becomes 1 by alpha. It's e to the minus alpha tau by minus tau, right? So I have a minus alpha coming up here. 1 by minus alpha. This is minus alpha tau from 0 to t. So I think the simplified answer straightforward comes to be minus alpha t minus alpha t. So this is 1 minus e to the minus alpha t whole divided by alpha. Okay, so this is the answer for y of t, the convolution result when the t value is greater than 0. Okay, so this is the continuous convolution, but ultimate thing is that you can trace what exactly is going to happen by using these graphs. No, it's a straightforward integration because this is constant. It's constant. Just integrate this one only. Okay. Yeah. So no. The integration happens with respect to tau, right? So any term which does not have a tau is a constant. Okay. So e to the alpha minus alpha t has no tau, so no need to do an integration. It's a constant. So I take it out, integrate only the e to the minus alpha tau. You have this part. Put the limits, you get this answer. Are you okay? I hope this is fine.